Hello video engineers, subscribers, viewers, and students. There is another video in hydraulics, particularly on pipe orifices. So here is the problem. The pipe orifice shown has a diameter of 100 mm and a coefficient of discharge of 0.65. The pipe diameter is 250 millimeters. The manometer connections are attached to a differential gauge partly filled with mercury. The remainder of the tube being filled with the same liquid as that flowing in the pipe, which is heavy oil of specific gravity 0.908 at 21 degrees Celsius. So compute the discharge in cubic meter per second when the difference in mercury levels in the gauge is 10.152.5 mm, 10.2690 mm, and 10.31.305 meters. So here is the given figure. So we have to apply or write energy equation between points 1 and 2. If we neglect head losses, then this velocity heads should be theoretical velocity heads. So that is 10.1 Q equals kaotog, where square root of 2gh is the theoretical velocity at point 2, and area O is the area of this orifice, which is 100 mm in diameter or 50 mm in radius. So writing energy equation between points 1 and 2 and neglecting head loss and the datum through points 1 and 2. So we have, by the way, let's check if the ratio of area 1 to area 2 is exceeding 16, so that we can ignore the velocity of approach or the velocity at 1. So pi over 4, 250 square, 250 mm square, over pi over 4, 100 square. So pi over 4 is cancelled. 6.25, which is less than 16. So therefore, we consider the velocity of approach. Or in general, if it is a pipe, we'll just consider the velocity of approach. Then, writing energy equation between points 1 and 2, take note that these are theoretical velocity heads. So velocity head theoretical at 1 over 2g plus pressure head at 1 due to oil plus z1, which is 0, equals velocity head theoretical at 2 plus pressure head at 0.2 plus elevation head 0. And remember, we ignore losses, that's why these are theoretical values. Rearranging, and so rearranging, we have P1 over gamma of oil minus P2 over gamma of oil equals V sub 2 square over 2G minus V sub 1 square over 2G. So call that equation 1. Then we apply continuity equation, Q1 equals Q2. We do not involve pi over 4 anymore, so 250 square V1 theoretical equals 100 square V sub 2 theoretical. Expressing V1 theoretical in terms of V sub 2 theoretical, it is equal to 0.16 of V sub 2 theoretical. So substitute this in equation 1. So we have P1 over gamma of oil minus P2 over gamma of oil equals 1 over 2g V sub 2 square minus 0.16 square V sub 2 square. So simplifying this expression here, so P sub 1 over gamma of oil minus P sub 2 over gamma of oil equals 0.9744 times V sub 2 square over 2g. So this is our working equation. Then we must find this difference in pressure heads between points 1 and 2 in terms of oil. So from the figure, beginning with 1, we sum up pressure from point 1 to 2, and we pass this pass along the differential manometer. So from 1 to 2, we have P sub 1 plus specific weight of oil times, we go down Y plus Z. So P sub 1 plus gamma of oil times quantity Y plus Z. Then we jump across to this point because these 2 points have the same pressure. Then we go up, so that's minus, take note this is mercury, so minus 13.6 times Z minus specific weight of mercury times Z rather. Then minus, this is oil, so minus specific weight of oil times Y. Then equals pressure at point 2. So take note that we can cancel gamma of OY here and this. So transposing P sub 1 of minus P sub 2 equals gamma of mercury times Z minus gamma of oil times G. Dividing everything by gamma of oil and factoring out Z in the right side. So we have P1 over gamma of oil minus P sub 2 over gamma of oil equals quantity gamma of mercury over gamma of oil minus 1 times Z. Since specific weight of mercury is specific gravity of mercury times gamma of water, and specific weight of oil is specific weight of oil times gamma of water, then minus 1 times Z. So we can cancel gamma of water. Therefore, the formula is for 10.1, P sub 1 over gamma of oil minus P sub 2 over gamma of oil equals 13.6 divided by 0.908 minus 1 times Z. So we compute that value, and it is equal to this difference in pressure heads between 1 and 2 is equal to 13.978 of Z. So for 10.1, we substitute Z equals 0.0525 meter of mercury, and therefore it is equal to, so the difference in pressure heads equals 0.7338 meters. We then substitute this into this formula here and equate to this so that we can compute theoretical velocity at point 2. So 0.7338 equals 0.9744 of velocity head theoretical at 2. So 0.7338 times 19.622 G divided by 0.9744. Then after that, the result, we extract the square root. So V2 theoretical is equal to 3.8439 meters per second. So the actual discharge is Kaotog, coefficient of discharge, area of the orifice by 0.05 squared, then times theoretical velocity. So coefficient discharge C 0.65, area O pi 0.05 squared, so that's Ko. Then this is the theoretical velocity at point 2, 3.8438. So Q is equal to 0.01962 cubic meters per second. Then for the second part, Z is 0.690 mm or 0.69 meters. Substitute here. So P's difference in pressure heads, P1 over gamma O minus pressure at point 2 over gamma O equals 13.978 times 0.69, and that is equal to 9.645 meters. Then we substitute into this equation here. 9.645 equals 0.9744 velocity head theoretical at 2. So we can now compute V sub 2, and it is equal to theoretical 13.936 meters per second. We then substitute into this equation. We just replace that by 13.936. So 0.65 pi times 0.05 squared times 13.936. So we have Q equals 0.07114 cubic meters per second. Finally, at 10.3, Z is 1.305. So difference in pressure heads is equal to 13.978 times 1.305, and that is equal to 18.241 meters. Then we substitute into this equation. 18.241 equals 0.9744 theoretical velocity head at 2. So the theoretical velocity head at point 2 is 19.165 meters per second. Then the actual discharge is, again, we use this formula here. We just replace this by 19.165, and I will not write that anymore here. You just calculate 0.65 pi times 0.05 squared times 19.165, and the discharge is equal to 0.09784 cubic meters per second. So that's it for this video. I hope that you were able to follow the explanations and the solutions.